Alright, so this is the quiz, the partner quiz to review. Right here you can see that Mr. Emmerman has worked out the problems that I'm going to talk through this here. So this first one's a parallelogram, where the unique thing about parallelograms is the base here is the same, top and bottom. So if we think about it, this slant height doesn't even matter. What really matters is the height, because this here, we could take this piece and put it over here and fill it in. We did that with the geoboard, so we just use exact same formula as rectangles. And that's what we see here for 120. This one's a little bit more difficult. You can use this formula here if you remember that. Otherwise, a really great strategy is to think about the triangles. So I see there's this really big triangle right here that's 24 by 5, but we know to find areas of triangles it's 1/2. And then we would do the same thing here. This triangle is 24, but it's larger by 16, and times it by 1/2. And find each of these and add it together, and we would end up with this. You can use this formula, but if you need to reason it out, that's a great strategy. Now with the trapezoids, the hard part is this base here is not equal to this base. So right here, we can take the average. So let's write a little bit different way. 11 plus 25, add it up, divide by 2 to get the average, and then times it by the height, and that right here should get us that amount. Alright, let's check in about the angles. There's some special things here because of these parallel lines. That means this angle here has to be the same as this one due to corresponding angles, so that's 55. You could just use supplementary math and take 80 minus 55 to get W. Or you could remember here that these two, because they're inside the parallel lines, are consecutive angles, so they add to 180. Either way, you'll get the same answer, and you'll get 125. This is not isosceles, so this is 1 tick mark, and this has 2. So this means if this is 60 here, these are again consecutive, so that means 120. Or you could have figured out the 60 with the corresponding and move forward. You do have to remember consecutive for this part, which means again is 120. Because these two together at 180 degrees. This parallelogram follows the same rule. There's 2 sets of parallel lines, which means these two inside the parallel lines have to add to 180. There's actually another set here, so that means also these two have to add 180. Following those rules here gives us all these, except for B. Remember, I have to remember an A. This side is always the same as this side on a parallelogram, as well as this side is the same as this side. So that gives us the angles by consecutive and the numbers on the outside by our rules about what a parallelogram is. Alright, the square takes a little bit more work. But you remember, or this rectangle. Remember, rectangles have the same sides across from each other. Opposite sides are equal. So I know there's 2 38s, so 38 times 2, and I subtract it from the total perimeter, which then gives us 50. That means this is 50 total for the 2, so that's why he wrote here 50 divided by 2 equals 25. Another way you could have done this is say 126, we know that's the total area. We know 38 plus 38 plus x, and then solves it using the algebra. Again, either strategy, just showing both. Alright, page 2. What's special in a rectangle is that this and this equal each other because the diagonals bisect each other. So that means in the algebra, I write this, solve the algebra down, and get 9. Actually, I had very few students miss that. If you might not have read the question, it does say the length of ln. The diagonals are congruent, so I need to plug x in to here. And then there are 2 of those, so that at that point you get 30. Okay. But you have to do it twice, and that means that we would end up with 60. Alright, let's look again at an angle problem. Right here we know that kites bisect at 90 degrees, so that makes this 90. Once we see that, there is a triangle here, and we could use our 180 rules from the very first unit to find this corner, and these two are the same, so that could help. This right here, again, this has to be 90, and these two are equal, so 8 and 8. That 75 can get us this, which then gets us this as well. Alright, this next problem takes a little bit of thinking to go through them. It says ln, this distance here, ln and OM are congruent. Okay, it's a little bit hard to tell in this. We could kind of measure out. Let's see here. Sometimes you can just use whatever tools. Well, already these are drawn to scale. It's not equal. You could draw yourself an exaggerated figure. Let's pretend that's a parallelogram. That distance is way shorter than that distance, so this does not make sense. Okay, triangle LON. So let me erase this diagonal, which should help us. Alright, saying this triangle is equal to this triangle. Let's see. This brings us back to proof. So this side is equal by reflexive. Okay, I'll put an R there for reflexive. These are equal because definition parallelogram. These are equal, definition parallelogram. Suddenly I have side, side, side would be the best justification to give for this. Okay. These other ones are also wrong, but let's just talk through them. OM is a bisector. That means they would cut at 90 degrees. That's not 90 degrees. Diagonals LN and OM are perpendicular. Again, that's 90 degrees. So this angle did not get cut in half in this one, and this one, they did not cross at 90. Alright, last problem. There's a couple different ways you could do it. A lot of people gave me a parallelogram. Also, you could have the right answer for trapezoid. So if you need me to talk through those, you can, but let's talk through the parallelogram. Opposite sides are equal if it's a parallelogram. Opposite sides are parallel. That means opposite angles are equal, and also these are consecutive. And we've got diagonals. They are not perpendicular. They do not bisect each other. They do not bisect the angles, but they... and they're not congruent. Okay, so, sorry, yes on this one, no, no, no. Okay, if you'd done the trapezoid, if it was isosceles, it would be no, 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 yes. If it was a regular trapezoid, not isosceles, it would be no, 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 no. Okay, again, talk through those with me if you want to. Probably the best first step is to go back to that first Thursday's homework where we did every single shape and went through every single rule. That could be a really great way to anchor yourself in these pieces. Alright, a lot of people just missed the point because they didn't justify. I'd be happy with quadrato, parallelogram, rhombus, and then saying it has to be rhombus because it fits, all sides are congruent, as well as these. Last one's here. A square is always a parallelogram. The opposite sides of a square are always parallel, so it's a parallelogram. A kite is never a rhombus. Rhombuses have all equal sides, kites don't. Rhombuses have parallel sides, kites don't. A rectangle is sometimes a square. Remember, a rectangle has two sets of equal sides. Square is 4, so if they all were equal, it could be a square. And that is our partner quiz. Very, very similar to our test coming up. So please review these, ask me questions, happy to answer any.